So this is a bit tricky question. You need to find out the oxidation of a number of phosphorus in BaH2PO2 whole twice, sulfur in H2S2O3, and sulfur again in H2SO5. So we do go on with the first part first. Phosphorus in BaH2PO2 whole twice. We know that barium is 2 plus and this is 2 minus. Therefore, the structure we are looking for is H2PO2 minus. Now we know that the summation of oxidation numbers of each of the atoms is equal to the total charge on the ion. Therefore, the oxidation number of hydrogen we know as 1. Let the oxidation number of phosphorus be x, and of oxygen we know as minus 2. Therefore, we write 2 into 1 since there are 2 hydrogen atoms, plus x minus 2 into 2 is equal to minus 1. Therefore, we get x is equal to 1. Therefore, the oxidation number of phosphorus in the first ion comes out to be equal to 1. Now, let us take the second case of H2S2O3. Going similarly over here, this is plus 1, this is minus 2, this is x. Therefore, 2 plus 2x minus 6 is equal to 0. Therefore, x is equal to 2. But this answer is wrong because we have assumed the oxidation number of different atoms to be equal to minus 2 and plus 1 and x. That is, we have assumed the oxidation number of both the sulfur atoms to be x, which is actually not true when we see the figure. So you must always be careful and always know as to how to find out the oxidation number from the structure of the molecule. Therefore, when you draw the structure of the molecule of H2S2O3, it is something like this. Here we have a oxygen and like this. Therefore, this we get as the structure of H2S2O3. This is hydrogen here and hydrogen here. Now, from this structure you should always see the difference in the electronegativities of the two atoms. Now, oxygen being more electronegative than hydrogen snatches this electron of the hydrogen towards its own side. Now, out of these two electrons, again oxygen is more electronegative than sulfur, therefore it snatches these two electrons also. Therefore, the oxidation number of oxygen becomes minus 2 since it has snatched 2 electrons extra. This becomes plus 1. Now, the electronegativity difference between these two sulfur is 0. Therefore, nothing happens to these two electrons. Now, again these two electrons are snatched by the oxygen. Again this electron of sulfur is snatched by this oxygen. Therefore, the oxidation number of this oxygen is minus 2. This one is minus 2, this is plus 1 and this one becomes 2 plus 3 plus 4. Therefore, the oxidation number of this sulfur becomes plus 4 because it has lost 4 electrons to its neighboring atoms. Therefore, we see that the total sum of all the oxidation numbers still comes out to be equal to 0. That is 4 plus 5 plus 1 6 and minus 6, that is 0. Therefore, we get the final answer for the oxidation number of sulfur in H2S2O3 to be equal to 4. The mistake which we were doing here is that we assumed the oxidation number of both the sulfur atoms to be same, which is not actually the case as we see here. The oxidation number of one of the sulfur atoms is 4, that is the central sulfur atom is 4, and the oxidation number of the other sulfur atom is 0. So in such cases, such doubtful cases, you should always draw the structure and find out the oxidation number. Again, in the case of H2SO5, we see that if we assume this to be plus 1, this to be minus 2 and this to be x, we get 2 plus x minus 10 is equal to 0. That is, x is equal to 8. But again, this is the wrong answer because we have done some mistake in assuming the oxidation number of one of the atoms. So we can draw the figure. The figure of H2SO5 is like, it has a peroxide linkage due to which the oxidation number of each of the oxygen atoms is minus 1. So the mistake which we did over here was that we assumed the oxidation number of each of the oxygen atoms to be minus 2, which is actually not the case. The oxidation number of this oxygen is minus 2, of this oxygen is minus 2, of this oxygen is also minus 2, the oxidation number of this hydrogen is plus 1, this hydrogen is plus 1. Now, this sulfur has lost all its 6 electrons of the outermost shell to its neighboring atoms due to the greater electronegativity of the surrounding atoms. Therefore, the oxidation number of sulfur becomes plus 6. Now, in this case also, if we add up the total oxidation numbers, we get the answer to be equal to 0. Let us check. 6 plus 7 plus 1 8 is equal to 2 plus 4 plus 6 plus 8. Therefore, still 8 minus 8 is equal to 0. The total sum of the oxidation numbers is equal to the total charge on the molecule, that is equal to 0. Now, from this we get the oxidation number of the central sulfur atom to be equal to plus 6. So, the answer in this case is plus 6. So, in the three parts we get the answer of oxidation number of phosphorus to be 1, oxidation number of sulfur to be 4, and oxidation number of sulfur to be again 6.